Hello everyone, welcome back to Real Time Systems. My name is Renuka, Assistant Professor in Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. In previous class we had studied about the interrupt handling. So now let us try to understand what do you mean by communication and what are the different ways a LAN is being connected and what is the bus topologies. Okay. So let us try to understand what is communication. It is how efficiently can an information be transmitted from one system to another system efficiently. Efficiently in the sense how 100% efficiency has to be achieved. But it's practically not possible. But yes, even if there is a delay between two systems, even then you do have a communication. So now communication is nothing but how well an information is conveyed from a source to the destination. Okay. So communication system in a plant is typically parallel or a short distance analog to digital conversion and requires a very high speed. So what do you mean by that? Communication systems in the sense if you take a plant, okay, we know that in a real time systems there are plenty of parallel operation happening in the single time duration, correct? So now if the distance between the plant and the processing unit, okay, when there is data which has to be sent, received from the processing unit or being monitored or controlled, right, because you'll be having monitoring and actuators, all these have to be controlled and monitored by a CPU if it is automatic or manual, right. Now when there is a short distance between a plant and the processing unit, what will happen? In the sense the distance between the two has to be short. Distance between what? Distance between the plant and the monitoring system has to be short because you should get the signals as quickly as possible. If you assume that the distance between the plant and the system is very far, by the time you would have got the signal, there will be some disturbance that might lead to some issues in a plant, isn't it? If valve might not close in the right time when it has to. So parallel processing is achievable when the distance between the plant and the processors is very short, okay, and a serial processing is possible only when you are thinking about a larger span, or you can say when you have a communication between one system to another system or one plant to another plant in a distant mode. Okay, then you have to go for a serial way of communication. So parallel fails for a long distance transmission of signal, right? That's the reason we have communication system in a plant is typically parallel and it has to be short distance for analog to digital conversion and requires a very high speed of operation. So that will be the first level of operation. Next you have communication over long distances are done serially beyond few hundred yards. So if there is a communication that has to be established from MITM to far off places, then what you have to do, you have to go for a serial communication. So parallel communication fails for a long distance. By that, distance between the source and the destination, if you are using any analog techniques in order to have a communication between the source and the destination, then what happens? The signal to noise ratio will be very, it has to be high. That is, evidently it has to be high for a better performance, but it will not be so, okay, if you are going for an analog interfacing technology, okay, because there will be a lot of interference. Fine. Analog systems are limited to short distances. So analog systems are limited very for a short distance systems. Parallel data transfer is expensive in terms of cabling and interfacing circuitry. So if you are expecting a parallel computation to happen between one system to another plant which is far off or remote places, then you need to have lot of wiring or cabling has to be done because the signal has to transmit, okay, either wired or wirelessly. You have to have a lot of technological interventions even both at the source as well as the destination. So economically it is not feasible for you to have a parallel computation for a long distance, okay. It is better for a short distance operation. So that can be understood by the help of this block diagram. There are three levels here. One is called level 1, the bottom, which forms the bottom part of this pyramid. which is parallel analog and digital transmission system, where it has a plant and many computers. So it is bidirectional. If you just see, the signals are sent and received from the computer or a controlling unit to the plant. So this forms a basic parallel processing unit which happens at the level 1, that is a high speed, and it needs a frequent data transmission between a system and a plant. Okay. This is where you have the parallel computation. As and when you go above, so beyond the parallel, that is level 2, you have asynchronous or synchronous network can be established here. Either it can be asynchronous, wherein the signals or a clock will be generated independently by each and every the destination and the source, and it will be sent, and the data will be sent on a transmission line. Okay. So that is asynchronous. Okay. They have different clock pulses, but in case of synchronous, for the same clock pulse you have multiple systems being communicated on a single data line. So now, so this will be your medium speed. Okay, that becomes your level 2. Then finally you have level 3, which has to be synchronous. Synchronous in the sense you need to have a same clock pulse has to be sent to all, so that you can monitor the entire plant. Okay. So it's just like a broadcasting. Okay. So here your parallel computation fails, right? So here you'll have a serial computation, because you need to you can't get the information then and there. Okay, as you have done with the level 1, it is not possible, right? You have to go for a serial computation here at the level 3. Okay, level 3, which needs or requires a high speed intermittent. Okay, from computer to another computer, which in turn sends a signal to the next level. Okay, so data transmission link, which plays a vital role in sending, receiving data from one computer to another. So based on that, in serial communication techniques, we can characterize them in different ways. Okay, what are those? First, coming up to the mode. What is the mode of transmission? Whether you're sending a data with a synchronized clock pulse or asynchronized. Okay, wherein each source and destination have their own clocks. Okay, and they send the data as and when on the transmission line. Okay, or synchronous. Next, you have quantity. How are you going to send the quantity? Is it character by character or block of character that you are going to transmit? Okay. Based on the distance, whether it is local or remote or a wide area that you are going to cover. Next, you have what kind of codes? Is it ASCII or any other kind of code? Kinds of coding techniques. Okay. Now, after knowing about the different transmission ways in which a serial communication is established, the mode of transmission. So first is the mode of transmission. Either it has to be asynchronous or synchronous mode of transmission. So what is asynchronous mode of transmission? Asynchronous transmission, where the transmitter and receiver use their own clock to gate the data on off the data transmission line, on or off the data transmission based on its own clock pulses. Okay, it will have its own clock pulses. Its own means it can be either source or the destination. They need not have the same pulse for the start and to end the data signal. Okay, the clock will be different for different processors. Okay, so that becomes asynchronous transmission. So asynchronous transmission is nothing but their own clock pulses, and with that clock pulses they are going to send the information onto the transmission line. Okay, an alternate approach is to use an additional physical connection, a clock wire, or so periodically to send a synchronizing signal, which means that you are sending a periodic signal to check whether the information which is being sent is received or not. It is a sync pulse, okay, between the transmission and the reception. Okay. Common form, a character by character used in telemetry or telegraphic code, which has a stop and a start system. So in telegraphic code, we all know that Morse code, wherein you have dot and dashes. So it is character by character is read. Okay, so that has a stop and a start type of system. So that becomes a character by character. So if it is bit synchronized, then you have character can be asynchronized. For example, if you take this clock pulse here, you have a start bit. If this is a data package, okay, I'm sending a block of data. So this block of data has 0 to 7 bits, okay. So there are 7 clock pulses. If you see 1, 2, 3, 4, 5, 6, 7, right. So these 7 clock pulses will be enabled with a start and a stop pulse. So you are adding 2 to 3 pulses along with the information. This is your data, right. This is the data. Along with this data, you are going to add a stop and a start to denote this is the duration, the entire signal to be sent from a source to destination. So what happens? A low transmission rate of frequency of clock signal generators do not have to be slowly matched. So which means there will be a delay when you have additional pulses being added to your mainstream. So there is a delay of transmission between the source and destination, isn't it? Because there will be n number of check procedures, right, when it reaches the destination. So the disadvantages, each character transmitted, each character here in an example we have taken 7 bits. Along with that you have 3 extra bits being added. Thus overall information ratio is it's very not very high. So information is not high, but along with that you have additional 3 bits which has been added. So you have the length of data becoming very big, okay, very long stream of data, right. So that is a disadvantage. The asynchronous system tries to overcome the disadvantage where a large volume of data over short period of time uses block synchronization transmission techniques. So here, instead of having a long complete stream along with the additional bits, in synchronization what happens? You have during the same clock pulse, okay, you have multiple such blocks of data being transmitted. So what happens? In one single clock pulse you have additional number of operations being performed, okay. So that is a merit of a synchronous system. Synchronous sequence is used to enable the receiver to sync with the transmitter clock. So synchronization sequence, if it is 0 to 7, so it will sync with that of the reception. So whatever being sent from a source has to reach the destination. That is a major intention. So there has to be a sync pulse which will be added to sync between the sent and the received data, okay. So that is done, for example, a block of 80 characters and each record is preceded by a synchronization signal and terminated with a stop sequence. So this is the best example. If you just see here, this is a packet of information. So bit synchronization, if you just see here, this is how it looks like. First you have a stream of binary bits here. You have zeros and ones, right? This is a bit synchronization. The same bits will be available at the destination, okay. So when this bit will be synchronized with the destination, then the data will be sent, okay, at that particular time slot. So you have a sync pulse in order to synchronize between the transmitter and the receiver, and then you have what is called as STX, okay, that is start of text, and you have end of text. And between the start of text, end of text, you have a text detail which is nothing but your data, right. ETX, all these are repeatable. The only difference is you have what is called as a block check. This will differentiate between one block of data to another block of data to make sure that it is not overlapped, okay. That is called as a block checker, okay. So this is how your bit synchronization pulse looks, when you are trying to transmit more than about 80 characters. So this is happening at one single, for one single clock pulse you have multiple such data being sent, okay, and it has been synchronized using the bit synchronization pulses here or the codes. To establish communication more than just a synchronization signal, just not having synchronization between transmitter and the receiver, it does not serve the purpose. So that's the reason we go for what is called as additional information regarding the data or the text is called as a protocol, okay. The protocol, first it says, it starts the transmission first, and then the bit synchronization, as soon as it receives, whether it checks whether it is 0 or 1. If it is 0, then it is disabled. If it is 1, the information is sent. Then you have a sync pulse which will say the synchronization of the source and the destination. If there is a synchronization, or if there is an overshot or if there is a delay, then what happens? The sync pulse will become 0, right? Again it has to be retransmitted, right? So the sync pulse plays a vital role here, because when the sync pulse will be sent continuously from the source to the destination should reply back saying that now I am ready, okay, to receive the data, for which it has to give an acknowledgement signal. Until unless it gives an acknowledgement signal, the sync pulse will be sent, okay. So receivers sends back a acknowledgement. So receiver will send an acknowledgement signal. So the bit pattern, in the form of bit pattern, either as zeros or ones, and there is a contact when it says that I am ready to accept the data. The bit sends the sync out during the idle period. So the receiver responds to the acknowledgement signal. Then what does it do? The line will be completely idle without end of when an end of transmission. So the completely it becomes idle once the transmission is happening between the source and the destination, or the transmitter and the receiver, okay. So text is broken into blocks, and each block is preceded by a start of text and the character, and ended with end of text. As you have seen in the previous example, you have what is called as a start of text and end of text, and you have the actual text which lies between the two ends, okay. Then this data will be sent from the transmitter to the receiver based on the synchronization. So until unless the synchronization pulse is being sent and received by the destination, and until unless the destination acknowledges, the information will not be sent, okay. So it will retry, or it will resend the signal again and again until unless it is as soon as it receives back the information, once the sync pulse is through, then the information is sent, and the information is in its the same format, wherein you have a start of text and you have end of text, and the text details are in between them, okay. And then you have block which will differentiate between the two information or two datas, okay. So now after knowing about the way in which you are going to have a different mode of communication, that is your synchronous or asynchronous, we need to know what is local or wide area network, because networks is nothing but it is system to system interconnect, okay. How are you going to interconnect? There is no hard and fast rule that a system needs to be connected in this particular pattern. It can be dependent on the kind of applications we are looking for, correct? So based on the number of computers that we are going to accommodate, and based on the area of coverage, there are different ways the entire networks could be classified. It could be wired, wireless, by the way the media of communication, or it could be analog or digital data. And if you are considering the number of system being connected, it can be a PAM, which is personal area network, or LAN, that is local area, wide area network, and metropolitan area network, okay. And that is how we are going to learn about what is LAN and what are the kind of topologies in LAN, okay. It can be twisted pair, coaxial cable, or it can be fiber optic communication or transmission with 240 megabits per second could be the data rate. So coming to the different topologies, if you just see the diagram here, there are different topologies in a LAN. How computers are interconnected, okay, and how are they, how the data paths, how are they interconnected, okay. The topology here mainly focuses on how are the computers interconnected. Okay. The first is what is called as a bus structure, okay. Then you have what is called as a star, then you have hierarchy, and then you have a ring. This is called as a mesh. So these are the different kinds of topologies that you are going to learn. So let us try to understand one by one in detail. So what is a bus structure? A simple bus structure is a passive, and all the devices are simply plugged into the transmission or the media, and it's passive, and the limitation is the length of the bus, okay, is that any transmission devices connected has to be able to transmit for a full length of bus. It has to be transmitted for the full length of bus. It cannot be short. It can't have any other path for transmission. Okay. Next, star. If you just take star, it is not that widely used, but definitely in certain data centers you have exchange, telecommunication applications, you have a node which are interconnected to different nodes. So if this node goes bad, the entire system breaks. Okay, that's the reason it is not that widely used, but yes, it has a bidirectional way of communication or transmission of signals. So a star, which is a central switch with a bidirectional transmission. The best example is private automatic branch exchanges, critical in operation. Why it is critical? Because if the center node breaks down, as shown in the figure, okay, if this breaks down, the entire signal that needs to be sent and received, the whole system breaks. Okay, so hierarchy or broadcasting accept new nodes. So what happens in hierarchical system is it overcomes the issue of star, but the only problem is you will not be able to have another new node being connected because it is pre-planned, so it is all wired. So you can't have a new node. If it is new node, then you have to change the whole setup. Okay, so that is a major difference between the star and the hierarchical system. Okay. Next, you have what is called as a ring. A ring is widely used and most popular. Why? Because you have a regenerative circuit in each and every node, okay, which can, and it can amplify the signal. Regenerative node along with the amplifying signals, amplifiers in each node. Okay, they contain a regenerative circuit and amplifies a signal. So information is placed in the network until the device removes the data. Unless the device will remove the data, the information is still will be there in each and every node. Okay, so it is like if you are taking a token from one ring, it goes to the next node and it passes unless it reaches back to the originating node. Though there is a delay in the path, but you can ensure that the information can be broadcasted for the different system whether you have the token or not. So again, based on how they actually access in a token mode or the token system, we shall learn in the coming up session. So now let us try to understand what is the mesh. Mesh is nothing but a random interconnection packet of information which is transmitted. So it is a randomness in the sense, if you just see there are multiple nodes here which are interconnected. So it will the data will try to always get into the path where you have a shorter distance will be actually used for the transmission of the data, but unless that line is free, otherwise it has to go to different routes. Okay, so now the routing here and again storing the data at each node, so there is a delay of time and a lot of time is required here to get the data processed, because sometimes there might be issue where even the data could be lost. Okay, so that is those are the few of the commonly used, because you can have different kinds of topologies. A mixed topology, it need not be the same, it can be a mixed topology where you have star with mesh, mesh with star, and many other configurations. Okay, so these are basically the 5 different types of topologies which are in your local area network. And coming up to the access mechanism, how you are going to access the data in case of a token ring. Okay, you can have either a synchronous token passing message, or it can be a slot, message slots, or it can be a simple token. So if you want to have a simple access mechanism to ensure one node transmits data at a time. So why we are going for access time is because if you are having 2 or more nodes, okay, if they are trying to communicate on the same instant of time, there can be intercollision of information on the same path. Okay, the data would be lost, right? So to ensure that the information reaches from the source to destination is vital, isn't it? That is the main purpose of any communication. The system should be efficient. the whatever information is sent from the source has to reach the destination at that stipulated time. That is a major entity of your entire communication system. Access mechanism plays a vital role. Here, access using the synchronous mode can be dealt under two different heads. One is called as a token passing, other is called as a message slot. Okay. Then using an asynchronous carrier, you can have senses multiple access, or it can have a collision detection, can also be implemented in case of asynchronous, because in asynchronous mode you have multiple data being sent on a same time, and it could be on a same transmission path. So a lot of carrier sense multiple access has to be there, and collision detection has to be dealt under asynchronous data transfer. So if you are just trying to understand about the token passing, there are three actions which can take place at the node, okay, when the token is being passed. The first is, if the message is from the node, okay, if a message is from the node, it is read and then it is marked as accepted and then replaced on the ring. Okay. It will be removed from the ring when it reaches the originating node, which means that there is a start point and there is the end point will be the start point. So what happens when there is information passing, okay, it will be read until unless the information is for that particular node, if it is generated from that node. Okay. So the node generates the signal and it will be checked. When it is checked, it will be passed on to the next. Okay. Until this happens, until unless it reaches back its originating node. Okay. That is the first one. That is how you are going to access the data or the message. Okay. If the message is not for that node, it will just simply, what does it do? It just simply replaces on this ring. So it will not check. So what does it do? It just places the information on the ring so that it could be passed on. Okay. Next, if the packet contains the token, okay, and the node wishes to transmit a message. Now there are three. One, first is the node will have an information that has to be read by other, correct, and it has to come back to the originating node. Second is whether the information which is being sent by the node is for the next node or not. The third is the node itself want to send an information. What does it do? What will it do? It will just remove the token on it, and then along with the new token, the information is added on and passed to the next node. Fine. So that is what is explained here. If the packet contains a token and the node wishes to transmit a message, then the token is removed, okay, from that packet, which is then passed on. Okay. Then the node then transmits its own information or the message, adding the token at the end of the message. So if you just take this as an information, so you have a starting delimiter and you have an end delimiter. Now this is the address, this is the data which has to be sent, okay, then there is a control, then you have a checksum. It will check whether the information to be transmitted. Checksum will be marked yes if it is for the next node, else it will not be checked. Okay. So until unless you have two data limiters, in the start delimiter and the end delimiter, the information will be sent along with the token. So this is how you are going to transfer the information from the node. So these are the different ways to access information at the node in a token ring system. Okay. So if you come to the standard interfacing, the companies usually have what is called as a real-time control that develops in a common standard interfacing system. So here, okay, I'll just go again. So we have what is called as standard interfacing. Why do we need to go for a standard interfacing system? Because when you're talking about not just the synchronization of information between the transmission and the reception to the destination, it is along with the protocol, right? How it has to be received, what should be there, whether the sent data is actually received by the right receiver. So these are the protocols, right? Along with that, you have to have a standardization. Standardization in the sense, when the computer, okay, you can't change a computer all along if you don't have a proper interfacing unit, right? If you have a data card, so you need to connect a data card to connect your system to the external world, isn't it? To have internet connectivity, right? The same way here, the companies which supply computers, they also have a real-time access. Earlier I have told you, each source and destination have their own clock signals, right? So these clock signals would be generated by an individual computer manufacturer, okay, which could be operated in its real time. So they will give an add-on card which could be added on to your CPU so that there could be an interface. So that's the reason to have a standard interfacing. Why should we have a standard interfacing? Okay, computer automated measurement and control. If this card is used, so what happens? Special cards are used to connect the system for different computers. Only requires that the card has to be changed, so not the entire system. If you can have CAMAC, then it is just an add-on card that has to be connected. So you don't have to change the entire system all along to get the access of any other data, right? There was an evolution in the field of standard interfacing, trying to get a modular kind of standard interfacing, for which you can just call it as a general purpose interfacing bus, which was developed by Hewlett and Packard company or a HP company, which had IEEE standards were used, where the interfacing card would connect about 15 devices at a time. Okay, so that was the next development. Later on, International Organization for Standardization, ISO, came up with OSI model, okay, which is taken as a basic model for any of the communication system, which has 7 layers, 7 levels or layers. So you can just see here, this is open system interconnection. This open system interconnection has a physical layer at the bottom, and top you have the application protocol. Okay, so physical layer, then you have data link layer, network layer, transport layer, and you have session layer and presentation layer. Finally, you have the application layer. So this is the OSI model, 7 different layers. So what is the operation of each and every individual layers? Let us just have a quick glance of it. So physical layer mainly defines the electrical and mechanical interfacing, okay, to a physical media, sets up maintenance and disconnects physical links, including hardware, IO devices, and modems would be there, and communication lines, and even the software devices. So these are basically the physical connectivity, okay, from one system to another system. Then you have data link, okay, establishes error-free data path over a physical channel in the sense it could be wired, okay. Frame messages, error detection and correction could be done. Then manages access to and use of channels, then ensures proper sequencing of data transmission. So because data transmission happens in a form of packets, so packets of information will be sent from source to destination. Probably you might have experienced if there is a variation in the internet connectivity, if the speed is not equal to that of the source, what happens? There will be a loss of packet. You will not be able to hear the voice simultaneously with the picture, correct? So that is a main important criteria here, that is called as a data link, okay. Then you have network, addresses and routes messages, set up communication paths and flow control. All these are dealt at networks. Flow control as to how the information will be sent from a level 1, level 2 and level 3. Then you have transport, provides end-to-end control of communication sessions, allows processes to exchange data reliably in the sense the data should not be hacked. So how efficiently are we sending the information from a source to destination will be taken care by the transport. It could be a file transfer, a simple file transfer. If you have a pen drive and you connect to a system and you want the information to be read from the pen drive, you want to copy some information out on your computer. So how do you do that? It is just a transport mechanism, right? Then you have session, establishes and controls node system independently, and then interfacing of transport levels to logical function in node operation systems. And then you have presentation, allows encoding data, because the digital information encoding data transmitted via communication path. To be presentation, how are you going to present? Is it graphical interface, or it just a file transfer, or is it like you have a data transfer? It can be a video. So all these are combined. This is how you're going to think about a presentation. Presentation layer takes care of this. Then you finally have the application based on the user, his desire, okay, to use the services. So allows the user services to be supported, that is resource sharing could be done, file transfers can be opted, and even for remote access, okay, if you're taking an example of video conferencing, okay, you're trying to connect multiple people at the same instant of time, okay, and you are virtually present. So that is one such example of application. So these are the different 7 layers, okay, in an OSI model that uses in a communications system as of now. So this is all for today. Thank you.